He knows a lot about the science stuff. Professor Dave explains.
For this problem, I've drawn a few different carboxylic acids, and we want to be able to rank them in terms of increasing acidity. So recall that acid strength is proportional to the stability of the conjugate base, and so go ahead and see if you can rank these properly. Okay, so in order to rank these in order of increasing acidity, we have to look at the conjugate base. We know that the conjugate base of a carboxylic acid, the carboxylate anion over here, we're going to have, this is the composite resonance structure. So the two resonance structures, we could have an oxyanion on one of them and then by resonance on the other one. So this is the composite resonance structure. We know that we have a formal negative charge. And so that negative charge is stabilized by resonance through pi bonds, but it can also be stabilized through the sigma bonds by induction. And so induction is when we have some electronegative atom. Remember that electronegative atoms are going to pull electron density towards them. And so this excess electron density in the form of a negative charge can be stabilized if there is some atom that through induction is able to take some of that electron density and hang on to some of it. So it's not the same as resonance, that's through pi bonds. Induction is through sigma bonds, but it is still a stabilizing effect. So if we understand that having electronegative atoms here is going to stabilize the conjugate base, then the question becomes which one stabilizes it best? So first of all, this one we know is going to be the least acidic because there are no electronegative atoms on it anywhere. So there is no induction happening when this deprotonates. But on the other ones, we have some chlorine atoms and we have some fluorine atoms. So what we need to understand is that the intensity of the stabilizing effect via the induction increases in two ways. Actually in three ways. It increases as the electronegative element becomes more electronegative and more able to hold on to some of the electron density. Number two, as that electronegative element gets closer to the site of deprotonation. And number three, if there are more atoms of them, right? So we have chlorine and we have fluorine. So putting this all together, over here we have a chlorine atom. This is less electronegative than fluorine, so it is less able to provide induction. And so this one is going to be next because it is weaker and further away. Now the next one, if we're comparing the rest of these three here, we can see that we've got a chlorine atom one away right there, and then we've got a fluorine atom one away. And we know that fluorine is more electronegative than chlorine, so it is able to offer more induction, and there's a greater stabilizing effect for the conjugate base. So we're going to call this one number 3. And then over here we're comparing one fluorine and two fluorine atoms. Obviously, having two fluorine atoms is going to generate even more induction and have an even greater stabilizing effect. So that means that this one is going to be next, and then this one is the most acidic. So once again, we're saying that these electronegative elements are stabilizing the conjugate base by induction. And then the correct order is as follows: no induction. A chlorine atom that is 2 positions away from the carboxyl carbon. And then a chlorine atom that is 1 position away because it gets more stabilizing as the chlorine atom gets closer. Then if we switch this chlorine atom to a fluorine atom, there's going to be even more stabilization because the fluorine is more electronegative. And then lastly, adding an additional fluorine atom is going to make even more stabilization because now there are 2 fluorine atoms. So the correct order, 1, 2, 3, 4, and 5. Thanks for watching, guys. Subscribe to my channel for more tutorials, and as always, feel free to email me, ProfessorDaveExplains@gmail.com.